How are you all? I hope you all are doing wonderful. So as you all know that I have started with the previous year question solving sessions on each and every topic of mathematics, and in this today's lecture session, and this is session number 10, and we will cover in the topic of probability. Alright, so if you have been someone who is new to this particular platform and started following this particular lecture, then I would request you, all of you, to go to the playlist of this particular sessions, okay, which you can find in the description box of today's video. And in the playlist, start following the videos from the beginning. Then only you will be able to connect yourself with the JEE previous year question sessions. Alright, so as you all know, the JEE examination is very near and your preparation must be very nice. So with this, I am taking the topic of probability, and you know the probability and statistics plays a important role in your JEE paper. Okay, so you can definitely guarantee like there can be 2 to 3 questions on the topic of probability and statistics, which can definitely guarantee you like 12 to 8 to 12 marks. Alright, so with this note, let's get started. So if you have been knowing that, today we will be solving the goal is probability, and we will solve the top 10 important JEE previous year question. So the very first important note before solving the question is that pause the video at this particular moment and try out the problem on your own and get to the answer, and definitely wait for me to complete the solution and definitely tally with your. After all, if you are done finishing all the problems with the video, then definitely comment me in the comment section how much marks did you obtain after completing the entire video. I'll be very happy to know from all of you. With this, let us start with the first question. Alright, so the very first question is on the screen. So the question says that there is a bag, and the bag which contains, so let me draw a bag. Okay, so there is a bag which contains 6 white balls, okay, which contain 6 white balls and 4 black balls. Okay, so let me write like this: there are 6 white balls, so I will be using the W for white, the W subscript for white, and B for black. Okay, so this is the bag. Okay, so the bag has 6 white balls plus 4 black balls, so there are total of 10 balls. Okay, so total balls will be equal to 10. Alright, so and it is said that a die is rolled once and the number of balls equal to the number obtained on the die are drawn from the bag. So, and corresponding to this particular event of drawing the ball from the bag, a die is rolled simultaneously. A die is rolled once. Okay, so our die is rolled once and the number of balls equal to the number of the number which is obtained on the die, and it is drawn from the random from the bag. Okay, so then we have to find out the probability that all the balls drawn are white balls. Okay, so first of all, let me say that, let me represent before drawing this conclusion or getting to the answer, let me write some of the variables. Okay, so I am denoting the random variable x. Okay, so in every problem of probability, you will find that there is a random variable, and the random variable basically is a measure of the quantity that is basically to measure, or the favorable outcome quantity. Okay, I hope you are understanding this if you have studied the chapter of probability. Then let us say that the x be the random variable. That means here the random variable is basically x is the number of the number of that is rolled on the die. Okay, so let me represent the random variable by the number which is rolled on the die, because based on that particular number, the number of balls will be drawn from the bag. So the number that is rolled on the die. Okay, so it is a number which is rolled on the die. So x be the number which is rolled on the die, and w, and let w, so this is capital W. Okay, so let w, or w, let me represent this as we can use this as w1. Okay, and so let w1 be the event. Okay, so this be the event when all the balls are white balls. Okay, so it is the event when all the balls are white balls. Okay, when all the drawn balls are white balls. Okay, so we have to basically calculate the probability. We have to basically calculate for the probability of getting white balls. So we have to calculate the probability of white balls. So that is the main thing that we need to find out in this problem. So now by using the law of total probability, so this particular can be calculated. So the probability of getting white balls can be calculated because there are two simultaneous events that is occurring, and based on one event the other event is basically related to each other. That means we have to can be calculated by by the total probability theorem, by the total probability theorem. Okay, so by using the total probability theorem, we'll basically get to the answer. What does the total probability theorem says? That for example, if I have an event, I have to find the probability of an event, then that particular probability of an event can be given as a summation of all the events. Okay, summation of all the events. So let me represent that summation of all the events, that is basically belong to this particular event set. Okay, and int multiplied with, for example, that particular event is dependent on some event, and let us represent that event as some sample event as S, and the event E is basically a subset of many events. So EI is the different events, and that are basically dependent on S. So that is EI, given that S has already occurred. So this is basically the main thing of the total probability theorem. Okay, the main crack of total probability theorem. So here also we will use a similar notation, and we will write that probability of getting the white ball is equal to sigma. So since there are it is a die which is rolled, so a die which is basically of a number. So what I can say that the random variable, that x can random variable actually belongs to the set, can belongs to the set 1, 2, 3 and so on up to 6. Okay, so the number which can be appeared on the die is basically 1 to 6. That means there are basically 6 events for which we have to basically find out for. So let me write that x belongs to 1 to 6. So I'm using the small x over here, and firstly I will write the probability of getting a white ball given that the random variable x is equal to small x, and that small x can be 1, 2 and 3 up to 6. Okay, into multiplied with probability of getting that number as equal to x, probability of getting the number on the die as equal to x. So that is the main condition of the total probability theorem. That's how we're going to find out the probability of getting a white ball. Okay, now from here what I can say that for each and every event, okay, for each number to be obtained, okay, for each number to be obtained on die, okay, that is the probability of x is equal to small x. Okay, this is a discrete probability distribution, so where x is equal to small x, and this small x basically belongs from 1 to 6, that is all are equal to 1 by 6. So the probability of getting 1 or 2 or 3 or up to 6 on the top of the die is basically has the probability of 1 by 6. Okay, so for all x belonging to 1 to 6, the probability is basically 1 by 6. So from here you got the probability, this particular probability result. Now you have to find for this particular case of probability, that is probability of getting a white ball given that the number is equal to x. So let us find out the different cases. So the first case will be basically probability of getting a white ball when the number x is equal to 1. That means the number of balls that is drawn from the bag is equal to 1. So what you will say do from here, you will say me that the probability of getting the white ball. So if you have the bag over here, so bag has basically 6 white balls and 4 black balls. Now the number of balls that is to be drawn from the bag is basically 1. So what is the probability of getting a white ball? That is, you will say that out of the 6 ball, choose any one ball, and what is the probability? That is basically 6 out of 61 divided by, and the total cases will be basically 10 balls, and out of the 10 balls you choose one ball. That is the probability of getting a white ball where the number of balls that is to be drawn from the bag, that is denoted by x, and x is equal to 1. And similarly you can also find the remaining cases of getting a white ball given that x is equal to 2. So that is basically 6c2 divided by 10c2 and so on up to similar result. Okay, and similarly for getting white ball given that the number of x is equal to 6, okay, given the number x is equal to 6, that is basically 6c6 divided by 10c6. Okay, and from here you can definitely get to the result, that is the total probability theorem. The probability of getting a white ball is basically equal to 1 by 6 into, now first result will be getting a white ball given that x is equal to 1, so that is 6c1 divided by 10c1 plus 6c2 divided by 10c2 and so on up to 6c6 divided by 10c6. Okay, so if you compute this particular result, you will definitely get to the answer. So let me do then compute the result. So 1 by 6 is basically common, so 6c1 divided by 10c1 is basically 6 by 10, that is basically equal to 3 by 5. Similarly the next result 6c2 divided by 10c2 is basically equal to 1 by 3. And for the third result, that is 63 divided by 10c3 is also come out to be 1 by 6, and 6c 4 divided by 10c4 is the result is equal to 1 by 14, and similarly 6c5 divided by 10c5 as the result is equal to 1 by 42, and this particular result 6c6 divided by 10c6 has the result 1 by 210. Okay, so that is the required result, and if you compute this required result and you compute this particular expression, so which you can definitely do on yourself. I have also done it for myself. Okay, so you will find this result will be basically equal to 42 divided by 210, and if you cancel out 42 divided by 210, you'll get the result as 1 upon 5. So the result of the probability of getting a white ball is basically of this entire event is basically 1 by 5. So with this you will get to the right answer to this particular problem as option number C. So the C is the correct option to this particular problem. I hope if you have solved this particular problem before me, you must have got the answer as 1 by 5. That is option number C. Okay, so definitely comment me in the comment section like how did you solve this particular problem, and how much time did you take to solve this particular problem. Okay, I am basically explaining you this particular problem. Otherwise, this is a very fairly simple problem on total probability theorem, which doesn't take much of time. The only time that is required is basically the computation part. Okay, so I hope you have done this particular problem, and definitely comment me in the comment section about the answer that you got. Okay, and what is your total score after solving the entire questions. All right, so with this let us move to the next problem. Again, so we got a next problem which is basically on the probability distributions. Okay, one of the most important probability distribution, that is the binomial distribution. So if you look at the probability distribution, so and in probability distribution you will find that there are two types of probability distribution. One are discrete probability distribution, and one is the continuous probability distribution. And out of the discrete probability distribution you will find the important probability distribution will include the binomial distribution. Okay, that is whenever Bernoulli trials are performed for a number of trials. Okay, when a Bernoulli trials are performed for n number of trials, then that particular distribution actually becomes a binomial distribution. If you have studied, you must know this particular terms. Okay, Bernoulli trials is basically a trial which has two basically outcome. One is either a success or either a failure. And if that success and failure are performed for a n number of trials, then that particular distribution actually becomes a binomial distribution. So it is said that the random variable. Okay, so we are given the random variable. Okay, so again a random variable. Okay, so random variable x, this follows a binomial distribution. Okay, so it is saying that this follows a binomial distribution b with a number of times as n and the probability of success as p. Okay, so this particular thing follows a binomial distribution with the number of trials as n and the probability of success is equal to p, for which the difference of the mean and the variance is equal to 1. Now for binomial so for binomial distribution, now you must have kept these things in mind. Okay, so let me first write the PMF function. Okay, now since this is a discrete distribution, so we can definitely write the PMF function, that is a probability mass function. That is a probability of x is equal to small x is basically will be given by NCx, okay, p raised to the power x into 1 minus p raised to the power n minus x. So that is the PMF of the function, that is the PMF of this distribution. Okay, now for getting the mean, okay, for getting the mean of this particular, so if we need to find the mean, okay, that is if I put like mean as x bar like this. Okay, so the mean of this particular will be given by the summation where small x belong to this capital X set. Okay, capital X set, where and given that we have to multiply x with the PMF function. So PMF function, that is f of x, p of x is equal to small x, and if you compute this result you will definitely find out this as n into p. Okay, so you can do this particular result and you just need to calculate summation of a binomial series. Okay, and if you calculate the summation of binomial series, then you will basically get to the value of mean. Okay, and the value of mean will be equal to np. Now you must have, if you studied this probability in your classes, or if you have studied this particular probability in your book, then you must not have came across this particular notations. Okay, this mean notation, or you must have skipped this portion. Okay, but I am taking in each and everything in very detail. I am explaining you like how you are actually getting this particular thing. I hope these are actually helping you in your preparation. Okay, so with this, and for getting the variance, so variance, that is variance. So for variance we basically need to apply the formula of expectation of x square minus expectation of x ka whole square minus expectation of x ka whole square. So if you compute this, you'll actually get to the variance, that is the central mean. Okay, or you can call it a central movement. Okay, central movement, variance is also actually a central movement. Okay, This is basically a non-symmetrical moment or non-central moment, and this is basically central moment. Okay, so this is also actually represented as expectation of x. Okay, mean is also equal to expectation. Okay, mean is the same thing as expectation. And if you compute this particular result for calculating the expectation of x square, so for calculating the expectation of x square, you again have to calculate the summation, and in place of x you put x square, and then you multiply with the PMF function, and then you calculate the result. You will get the result, and if you compute this particular expression, you will find the result as n into p into 1 minus p. Okay, so that basically becomes the variance of this particular binomial distribution. Okay, and in the question it is mentioned that, so in the question, so I will write this, according to the question it is said that the difference of the mean, okay, the difference of the mean, that is np minus, and the variance, that is np into 1 minus p, and the difference is equal to p, and the difference is equal to 1. Okay, so we have the difference is equal to 1. So from here let me take out the common terms. So if I take np as a common, this will become 1 minus of minus p, and that is equal to 1. So from here if I compute the result, so from here if I see the result, that is np into 1 minus 1 plus of p, okay, plus of p, and the result is equal to 1. So 1 and 1 get cancelled, and from here you will get the result as np square is equal to 1. Okay, so you got the result as np square is equal to 1. So let me label this as equation number 1. So let me label this as equation number 1. And with this also it is mentioned in the problem that 2 times of probability of x is equal to 2 is equal to 3 times of probability of x is equal to 1. Again, another important that is given, that according to question that is given, there is 2 times of probability of x is equal to 2 is equal to 3 times of probability PMF function of x is equal to 1. Okay, now here comes the importance of PMF function. So we will use it 2 into x is equal to 2, that is nc2 into p square into 1 minus p whole raised to the power n minus 2 is equal to 3 times of nc1, okay, nc1 p raised to the power 1 and 1 minus p raised to the power n minus 1. Now the terms over here, we just need to cancel out these terms. Okay, so for here this particular cancellation, we'll do this as 2 by 3, and this is nc2 divided by nc1, and p will be left over here, and over here you will be left with 1 minus p. Okay, 1 minus p ki power n minus 1 minus of n minus 1 plus 1. Okay, I'm just dividing, so you will get this as 1. Okay, so you just cancel out this, okay, this with this, and you will be left out with 1 minus p ki power 1. And if you take p from this particular side, and you can write this as like this. Okay, now why I am doing this you will understand in the next particular step. Okay, so from here we have also studied the formula, that is NCR divided by NCR minus 1 is basically equal to n minus r plus 1 divided by r. So with this, if you compute the result, you will basically get this as 2 by 3 into n minus, okay, so also you can do this as n into n minus 1 divided by 2 divided by n. So okay, so from here you will also get the result as n into n minus 1 divided by 2 and divided by n. So the result you will get over here is basically n minus 1 divided by 2, and that is equal to 1 minus p by p. Okay, so you got to the result of 1 minus p by p is equal to n minus 1 by 3. Okay, n minus 1 by 3, because 2 and 2 got cancelled, and from here if you cross multiply, okay, so n minus 1 by 3 is equal to 1 minus p 1 minus, so from here you'll get the result as 1 minus p 1 minus p by p. Okay, and if you do this simplification, if you do the simplification somehow like this, that is 1 by p. Okay, so 1 by so if I take 1 by p as common, okay, so what you will, sorry, if I take p as common, so you will find this, before doing this I can write this as 1 by p minus 1, and then if I take p as common, then I will write this as 1 by p square minus 1 into p is equal to 3 into 1 minus p. Okay, so I can write like this. Okay, 3 into 1 minus p. What I did, I basically multiplied over here by this particular term, and then took the common p as common. Okay, and doing this, okay, so if you are done doing this, okay, what you will find out the result as, so you can definitely perform this expression, and you will find the result as 1 minus p square, and that can be factorized as 1 minus p into 1 plus p whole divided by p, because I cancelling again p square with p, and the result will be equal to 3 into 1 minus p. Okay, so from here if I cancel 1 minus p and 1 minus p over here, so I will get a 1 plus p is equal to 3p, and with this result you will get the value of p as 1 by 2. you will get the value of P as 1 by 2. Okay, so from here, if you go on cancelling out, and you will finally get to the value of P as 1 by 2, because what I basically I used the value of np squared is equal to 1, and from np squared is equal to 1, I just put the value of n is equal to 1 by p square. So that's what I did from over here. Okay, so I did this particular, okay, and then I took the p as common, and then I performed this particular result. Okay, so I missed out saying this particular step, that I put n is equal to 1 by p. So from here I actually put n is equal to 1 by p square. So okay, so I just put 1 by p square, and on this particular, and then I factorize out, and I got to the value of p as 1 by 2. So if you have the p value as 1 by 2, so from there you will get the value of n as 4. So from there you will get the value of n as 4. Okay, so if you have done now with the simplification, then in the next problem it is actually asked to calculate the value of, it is asking the problem to calculate the value of n square probability of x greater than 1. So in order to solve this particular probability of x greater than 1, I can use the calculation as n square value is basically equal to, so I got the value of n as 4, so n square is equal to 16, and value of probability greater than 1 is nothing but equal to 1 minus probability of x is equal to 1, because x value cannot be equal to 0, so there are no negative results also. Okay, sorry, the x value cannot be negative. Okay, so that is a 1 minus probability of x is equal to 1 minus probability of x is equal to 0. So okay, so if you calculate these particular results, then you basically get to the answer, that is n square p into p of x minus x greater than 1. So if I erase this particular, so let me clean this. Okay, so let me clean these stubs, and I will be using this particular space. Okay, so from here let me continue. So n square p of x greater than 1 is basically equal to 16 times of probability of p x greater than 1 is basically 1 minus probability of x is equal to 0 minus probability of x is equal to 1. So if you remove these two probability, then only you will get from the entire set, and the probability of the entire set, entire event or the sample event is basically 1. So 1 minus probability of x is equal to 0 minus probability of x is equal to 1. So you will get to the required answer of probability of x greater than 1. So from here if you calculate, that is 16 into 1 minus probability of x is equal to 0, that is basically n is value is equal to 4 and c 0, and probability value is half 1 by 2 ki power 0 and 1 by 2 ki power 4. So you have basically 1 by 2 ki power 4 minus 4c1. So from here also you will have 1 by 2 ki power 1 into 1 by 2 ki power 3, and that will be again 1 by 2 ki power 4. So if you calculate this particular result, and which I have done on my own, okay, so you will calculate this particular result, you will get the answer as 11 by 16, and if you multiply 16, that is basically 11. So if you calculate this, the value will be coming out as 11. So with this, again you will have the correct option as C. So I hope you have understood this particular problem, and you must have solved this particular problem, because fairly simple problem. If you know the results, you are basically actually able to do out with this particular problem. It's a fairly simple problem, okay, but very important, because in examination there are problems which are repeated on binomial distributions. Okay, so you must keep this particular thing in mind. Okay, all right, so with this, let us move to the next problem. All right, so the next problem says that there is a coin, and the coin is biased. Okay, so instead of giving an unbiased coin, the coin is said to be biased coin. So we are given with a biased coin. Okay, so let me change the color first. All right, so we are given the biased coin, so that the head is 3 times as likely as to occur as the tail. That means it is saying that the given probability of the head is basically 3 times that of a tail. So from that particular conclusion, what I can say, that the probability of getting a head is basically is 3 times as likely as to get a tail. So from here I can say the probability of getting a head is much more favorable than to get a tail. So from here what I can make a conclusion is that the entire probability, so for example, if there are only two outcomes of a given subset of this given entire event, has basically two events can be possible for the given sample space. So for the given sample space, only two events are possible, that is head and tail, and out of those the entire summation, okay, if I add of all the events, okay, if I add up all the events of the sample space, then I will get the result as 1. So from here, if you apply these two conditions, you will basically get the probability of getting head is equal to 3 by 4, and the probability of getting a tail is equal to 1 by 4. Alright, so from this biased coin, instead of given a unbiased coin, this coin has a probability of getting a head as 3 by 4 and getting a tail as 1 by 4. Now it is said that this coin is tossed until a head or a three tails occurs. Okay, until a head or a three tails actually occurs. Okay, or three tails actually occurs in simultaneous. So if it is said that x is denotes the number of tosses. Okay, so x is a random variable which basically denotes the number of tosses of tosses of the coin. Okay, then I have to find for the mean of the x, that means expected value of x. All right, so this particular question can be actually solved by taking conditions. Okay, now what I can say that the random variable x can actually take values, can take values. It is said the coin is tossed. Okay, this coin is the coin is tossed how many times? So maximum number of coin that can be tossed is basically 3 times, because this coin is tossed until a head is appeared or any three tails simultaneously occurs. Okay, so that means the maximum maximum of trials is basically 3. That means maximum number of trials to stop this particular experiment is basically equal to 3. Now from here what I can say that means the random variable can take values 1, 2 and 3. Okay, 1, 2 and 3. Okay, any of these particular 3 values they can be taking the random variables. All right, so from there what I can say that if x is equal to, if x has the value 1, okay, so if I say the x is equal to 1, that means the experiment is completed when the head is occurred. That means a head is obtained. A head is obtained. Okay, a head is obtained in the first throw. Okay, in the first toss, a head is obtained in the first toss. That means this will happen only when the probability of getting a head is basically 3 by 4. That means on the first toss you basically get the probability as 3 by 4. Now this is also equal to the case when the random variable x is equal to 1. Now again for the different cases, let me from when x is basically equal to 2. That means a tail is obtained. A tail is obtained first. Okay, a tail is obtained first and then head. Okay, and then a head is obtained. So that means for this particular experiment to end in the two trials is basically the probability is basically equal to, firstly you get a tail that is 1 by 4, and then so we are using the multiplication, and then you get a head that is 3 by 4. So with this the probability will be equal to 3 by 16. Okay, 3 by 16. And similarly if x is equal to 3, that means this case can only possible when either either two tails occur, and then a head occurs. So these all the questions are basically solved by, okay, this is the first case and the second case. Okay, so again I'm talking about and, that means I have to use the operator that is plus. When I'm talking of, when I'm using the different cases, I mean to say that I'm using the word or over here. Okay, so when I'm using the word or, I will use the condition that is addition, and when I will use this is and, that also need to be occurring together in order to get it, then only I will be using the operator that is multiplication. Okay, so these are the very basic theorems that you must have studied in permutation and combination, so you have understanding that why we are actually using them. Or there can be a case when three tails simultaneously occurs, okay, or three tails occur. So the probability that is x basically equal to 3 is equal to the case when two tails occurred in simultaneous, okay, in continuation, that is two tails, that is 1 by 4 into 1 by 4, and then a head occur, that is into 3 by 4. Or the case when all the three tails occur together, that is 1 by 4 into 1 by 4 into 1 by 4. So from here you will get the condition as, so you will get from here is basically 3 by 64 plus 64, that is 4 by 64, and that is basically equal to 1 by 16. So from here you will get the value as 4 by 64. This result is equal to 4 by 64, that is 1 by 16. That means for the different cases, for discrete cases, we actually have the PMF function. Now the PMF function, that is the probability mass distribution function for the discrete distribution, that is when x is equal to 1, the result basically equal to 3 by 4, or better write it as, so if I multiply by 4 on both the side, that is numerator and the denominator, I will get it as 12 by 16. Similarly, the PMF for x is equal to 2 is basically equal to is basically equal to 3 by 16, and the value when x is equal to 3 is equal to 1 by 16. Okay, 1 by 16. So from here I have the PMF function. Now I have to find for the expected value or the mean. Now I have already told you that expectation or mean is basically given as summation for x all belonging to the sample space, that is x into the PMF function, the x into the PMF function. Okay, and if you compute this result, that means for expectation value this result will be equal to, so x value is 1 into, and for the one case the corresponding probability is equal to 12 by 16. Okay, for the case when x is equal to 2, the corresponding probability is 3 by 16, and the case when the x value is equal to 3, the probability is 1 by 16. So from here if you calculate this is 12 by 16 plus 6 by 16. So the result will be coming out as, so from here I'm evaluating the result as, so 12 plus 6 plus 3 divided by 16. So this particular value will yield in, okay, so 18 plus 3 is basically 21 by 16. So the answer to this particular problem will be equal to 21 by 16, and that is option number C. Okay, so if you have solved this particular problem on your own, you must have got the answer as option number C. I hope this particular problem was clear. Very simple problem. Okay, if you have studied this entire thing of chapter and you have the basic concepts clear, then this question is just a cake for all of you. Okay, now these types of problems are actually important because many shift these types of problems actually get repeated. That's why I have taken up in the important problems of probability. I hope you are getting my point. Okay, so let us move to the next problem, and the next problem is again a very important problem, and that is basically a problem when two of the dices are actually rolled. So it is saying that there are two dices. Okay, so two dices, one of them is labeled as A and B, are rolled together. Okay, so two dices are actually rolled. Okay, so two of the dices are rolled, and let the number obtained on A and B be alpha and beta respectively. So the number which is obtained on A is basically alpha, and the number which is obtained on B is basically equal to beta. Now it is saying that the variance of alpha minus beta. So there is another important thing that you need to understand, that instead of creating the random variable as the alpha or beta, it is saying the random variable is basically alpha minus beta. So whatever it is a number that is appearing on the two dices, the difference of these two number is actually the random variable. Okay, now from here you can say that the alpha minus beta is a random variable, and it is said that if the variance is basically equal to p by q, where p and q are co-prime number, then the sum of the positive divisors, of p is equal to what? Okay, so this is a very new and challenging problem in itself. Okay, so students who have studied this chapter, okay, and they must have gone through this, they must have not gone through this types of definitely these kinds of problems. Okay, so that basically makes this an important problem for your 2024 upcoming examination. Okay, now I will be giving you the way to solve this particular problem as a form of a cases. Okay, so what I will do, I will make some cases. First of all, tell me what will be the value of alpha minus beta. What can be the maximum and the minimum value of alpha minus beta? That is alpha value. If alpha value is equal to 6 and beta value is equal to 1, then the maximum difference is equal to 5. Okay, and similarly the corresponding case, if it get interchanged, then the result will be like the alpha value is equal to 1 and the beta value is equal to 4, then the minimum difference will be equal to minus 5. That means the range of alpha minus beta will basically range between minus 5 to plus on 5. Okay, so that is an important thing that you need to understand from here, that is from plus 5 to minus 5, the minus 5 to plus 5, that is the range of alpha minus beta. Now I have to make some cases for it. Okay, so if I say that alpha minus beta will be basically difference is equal to 5, that will correspond to cases. What of the cases can be possible? Okay, so I have to form cases from here. Now the only possible case that is possible is when the dice A has 6 and the dice B has 1, that is 6, 1, and for this particular case the recurrent probability, so I am writing this as a probability, so the recurrent probability will be equal to the first case 1 by 6 and the second case 1 by 6, and then if you multiplied it, the probability for getting 6, 1 is basically 1 by 36. Okay, similarly the difference is equal to 4. When are the possible cases? What are the possible cases for difference is equal to 4? The possible cases are 6, 2, and the other case is basically 5, 1. So that means you have 1 by 36 plus 1 by 36, and that will basically correspond to the probability as 2 by 36. So for these two cases, the probability is basically 2 by 36, and so on if you evaluate, so what are the differences? Okay, the differences can be 3, the difference can be 2, the difference can be 1, the difference can also be equal to 0. So I'm writing over here the difference. Okay, I'm solving in a graph. Okay, so I'm making you to understand. and then I'm writing the probability over here. Okay, so the probability over here, the difference can be -1, the difference can be -2, the difference can be -3, difference can be -4, and difference can be -5. Okay, so these are the various possible cases. Okay, these are the possible values of alpha minus beta, and corresponding to all the values, the possible case for the numbers which are obtained on the dices can be, so for 3 the number can be 6,3, okay, 5,2, and 4,1. Okay, so there are 3 possible cases, and that will give the corresponding probability as 3 by 36. And similarly, for the difference to be 2, the values can be 6,4, okay, 5,3, similarly 4,2, and 3,1. That are the possible cases for 2, and that will correspond to the probability that is 4 by 36. And similarly, corresponding to the result of 1, the result will be the results are equal to 6,5, okay, 5,4, okay, 4,3, 3,2, and 2,1. So there are 5 possible cases that will basically make the probability as 5 by 36. Okay, and similar fashion, if you look at 0, the case can only be 6,6, okay, 5,5, similarly 4,4, 3,3, and so on up to 1,1, 2,2, and 1,1. So there are possible 6 cases, and the probability will be equal to 6 by 36. Okay, 6 by 36. Now similar case will occur for -1. Also the similar number of cases can be 5,6, okay, 4,5, 3,4, and similarly this that means this particular probability for the result when alpha minus beta is also equal to -1 will also have the probability same as 5 by 36. Similarly, for -2 the probability will be 4 by 36. For -3 the probability will be equal to 3 by 36. For -4 the probability will be equal to 2 by 36, and for -5 the probability basically equal to 1 by 36. Only in the possible cases, the only thing that will be difference is basically in place of alpha the beta value will be get repeated. Okay, they will get interchanged. That's the only difference. Okay, so from here you basically get to the following cases, and if you have the cases, what I have to calculate is basically you have to calculate the variance. Now you know the variance of x is basically expectation value of x square minus expected value of x ka whole square. So if in order to find the expectation of x square, what I need to do, I need to sum up for all x which is belonging to the sample space. Okay, so I'm writing the sample space as S for all x belonging to the sample space. Okay, and I have to multiply with x square into the PMF function. So I have the PMF function for x is equal to x, and this will basically give me the expectation value of x square. So if you calculate this, the result is going to be, okay, so for x is equal to so what are the values of x? X are basically these particular values. Okay, because our random variable in this particular problem is basically alpha minus beta. That means the value of x is basically the value of alpha minus beta. The value of x is equal to alpha minus beta. So from here you'll firstly get 25 multiplied with the probability that is 1 by 36, plus for the case when it is 4, that is 16 into the case the probability is basically 2 by 36, and so on. Okay, so on you have to multiply. And also what you can see that these particular cases from 5 to 1 and -1 to 5 are basically repeated cases. So what can I do, that instead of instead of adding and writing all, I can do this as 2 times of the addition up to 1 into 5 by 36. Okay, and for the sixth case, that is the number is when the random variable is equal to 0, the probability is 6 by 36, that is 0 into 6 by 36. Okay, and from here if you evaluate the result is going to come out as, so what I found out the result is basically 105 divided by 18, that is basically equal to 35 by 6. Okay, so I got the expectation value of x square is equal to 35 by 6. And similar fashion, if you find out the expectation of x, okay, and similar fashion if you find out the expectation of x, what is the expectation of x? That is basically going to be the summation for all x, that is x into the PMF function of x is equal to x. And if you sum for all the sample space, the result is going to come out as, so if you do this expectation, the expected value of x is basically going to come out as 0. Okay, because this is very obvious, because the probability for the positive numbers and the probability for the negative number is basically the same, and they get cancelled out, so the result is going to be 0. That is basically very symmetric data is present. So from here what I can say, the variance of x is basically going to be the expectation of x square, because expectation of x is basically 0, and that result is equal to 35 by 6. Okay, and that is basically equal to 35 by 6. And if you can know that this 35 and 6 are both of them are co-prime number, that means this is equal to p by q. Okay, and this is equal to p by q. So from here I got to the value of p as, So from here I got to the value of P as 35. So if I have the value of P as 35, now I have to get to the positive divisor of P. So if I have the number 35, so if I have the number as, so the number P as 35, so what are the divisors? The divisor of 35 is 1, 5, 7 and 35. Okay, so these are the possible divisors of 35. So what are the sum of this? The sum of all these numbers, the sum of all this divisor is going to be equal to, so you can see over here 40 plus 1, 41 plus 8 is basically equal to 48. And with this, the right answer to this particular problem is going to be option number A. So fairly simple problem, but okay, in a unique problem, okay, because mostly people do not encounter these types of problems where the random variable actually gets changed in a different manner. Okay, so this is basically change random variable. Okay, now in your college level college level courses or probability statistics, you will be understanding the importance of random variable and what is the transformation of random variable. So you can definitely understand this particular problem is a problem on transformation of random variable or single random variable. Okay, so I hope this particular problem is clear. So with this, let us move to the next problem. Alright, so the next problem is an important problem which is basically on the topic of matrix. Okay, so we have to use the concept of determinant in this particular problem. The problem says that there is a matrix, there is a sample space which contains all the matrix M such that A of ij, okay, A of ij, where A of ij can take only the elements 1, 2 and 0. Okay, 0, 1, 2, and where I and j are both less than or equal to 1 up to 1 and 2. Okay, so that means this is a matrix which is of order 2 cross 2. That is basically given identity over here, and this is a sample space. Okay, now firstly let me get to the total number of total elements in the sample space. So the summation number of elements in the sample space is basically equal to, so there are three possible numbers which can be possible for all the elements. That means I can represent the matrix M as A, B and this is C and D. That means for each of these particular numbers A, B and C and D, there are basically three cases, and three cases for four elements, that the total number of sample space is basically equal to going to be 3 to the power 4, and that is basically equal to 81. Now I have to look for the sample event A. Okay, now I have to look for event A. Now I have to look for event A. Now event A is basically where all the matrices belong to the sample space M such that M is an invertible matrix. Okay, now what do you mean by invertible matrix? That means such a matrix which is basically having the determinant value. So the determinant value of this matrix is non-zero. That means such a matrix is basically inverted. That means is inverse of that particular matrix is possible. That is only possible when the determinant value of that matrix is basically non-zero. Now for getting the invertible matrix, okay, now in order to solve this particular problem, we have to make some cases and solve this particular problem. So what an important thing that you are going to understand in this all concepts of probability is basically making of how to make cases and corresponding to cases how to get to the probability result. Okay, so that is very important. Now matrix is invertible. Okay, matrix is invertible. Okay, if and only if determinant value of this particular matrix is non-zero. That means if the matrix has A, B, C and D as the element, corresponding element, then the determinant value is equal to AD minus C into B, and that should not be equal to 0. Okay, so that is an important case from here. Now instead of doing the cases for finding out that is not equal to 0, let us find all the cases where this vertical value. So let us find the cases where the matrix A is non-invertible. Okay, non-invertible. So let us firstly find the cases where the matrix is non-invertible. That means AD minus BC is equal to 0. So let us find for all the cases where this particular approach or result actually holds true. So for the first case, so let me make the first cases. Okay, so the first case over here is that when AD is equal to BC and that is equal to 0, that means all of the values are equal to 0. So that is the possible cases, that when all of the elements are equal to 0. Okay, also when any one of the element is also equal to 0, that can be also case. Okay, any one of A or D or B or C is equal to 0, that means A and D can be chosen in the fashion that can be 0 comma 0, okay, 0 comma 1, okay, 0 comma 2, and similarly 1 comma 0, okay, 2 comma 0. So there are basically 5 cases. So what you can say, there are basically 5 cases, and similarly for B and C there are also 5 cases. Okay, so for B comma C there are also 5 cases. So that means for this first case, for when AD is equal to BC is equal to 0, the following will be total possible matrix. Okay, total possible matrices are basically 5 into 5, that is basically 25 possible matrices. And similarly, let us take the second case, and the second case says that when AD is equal to BC is equal to 1. Okay, now when both of them are equal to 1, then the difference is also equal to 0. So that can be the cases are basically when A comma D, A into D is basically 1 comma 1. Okay, and similarly when B comma C is also equal to 1 comma 1, that means there is only one cases. Okay, so there is only, so corresponding to this particular case, there are only one case. Okay, so there are only one possible matrix for this particular case. And similarly the case 3, when when A into D is equal to B into C is equal to, now what is the maximum value of the product of these two, A into D or B into C, can be, that is basically 4, because when both of them are equal to. Okay, so I have to take 4 cases. So let me firstly get to the result for case number 3. AD is equal to BC equal to 2, that is the possible cases when A comma D is equal to 2 comma 1 or 1 comma 2. So there are 2 cases. And similarly for B comma C also there are 2 cases. So from here you will get basically 4 possible matrices are possible. 4 matrices possible. Similarly for case 5, case 4, when AD is equal to BC is equal to 4, that is this correspond to also one possible case. This also correspond to actually, so this also correspond to actually one case. Okay, one case or one matrix possible, that is when A comma D is equal to 2 comma 2, and similarly B comma C is also equal to 2 comma 2. That is only one possible matrix. So from here all these particular cases, what I get, the total number of matrices when for which this particular case is non-invertible are equal to 25 plus 1 plus 4 plus 1. So that will basically yield you the result that is equal to 31. Now these are the possible cases for non-invertible matrix, but I have in the question it is mentioned we have to find for invertible matrix. So the total invertible matrix can be, so if invertible matrix is possible, then the possible cases are, in the ways are possible ways or possible matrix are basically from total you minus the cases when what there are non-invertible, so that is 31. So if you minus it, the result is going to be 53. Okay, so from here the result is going to be, sorry, there is 81. Okay, so what I'm doing, this is 81. Okay, so the result is going to come out as, 50. Okay, so these are the possible cases for the when the matrix is invertible. There are 50 possible invertible matrix. So you have to find for the probability of the event A, that means the probability of event A. So in the problem we have to look for the probability of event A, that is the number of elements in the set A divided by total number of elements in the sample space, and that will basically yield out the result as 50 by 81. 50 by 81. With this, the right answer to this particular problem is going to be option number C. Alright, so fairly important problem. Okay, now these types of problems are actually very important for the both the topics of probability as well as determinant. Okay, now this is a very important question which involves both the ideas or topics. Okay, so I hope you will remember this types of problem. And these types of problems are actually more of asked in JEE advanced problems. Okay, so if you have looked the JEE advanced previous year problem, you will find that these types of problems are actually asked in JEE advanced 2012 paper. Okay, in a numerical type problem. And similarly, if you look at the comprehensive type problem or JEE advanced 2010, you will also find a similar problem which basically use the concept of permutation and combination and probability in the topic of determinants. Okay, so you can definitely try out those problems on your own. Alright, so with this let us move to the next problem. So the next problem is on the screen, and it says that let a die be rolled n number of times, and then if a die is rolled n number of times and the probability of getting an odd number 7 times. Okay, so probability of getting an odd number 7 times is equal to the probability of getting odd numbers 9 times. So let us understand like what kind of probability distribution is this particular problem. So the total trials, okay, total trials is equal to n. So if there are n trials and in this n trials the die is rolled, okay, die is rolled n number of times. Okay, and so if you look at the die, so the possibilities, okay, the possible numbers on the die are basically, so if I say the possible numbers, the die's possible number are from 1 to 6. Okay, now if you look at these particular numbers, so out of this 1 to 6 there are 3 odd numbers, okay, 3 odd numbers and 3 even numbers. That means the probability of getting a even number is also equal to the probability of getting a odd number basically, and that is basically equal to 3 by 6, that is equal to half. So if you look at this particular distribution case, the probability of getting a even or odd number is both of them are equal and they are equal to half. Now that basically simplifies this particular problem, that whenever the probability of getting the, we have basically two cases for this particular die, that is one of them is success and one of them is failure. So this particular scenario or problem is basically under the distribution of binomial distribution, because for the following problem or the distribution, we basically have again two events, either success or either failure, and then they are basically rolled for n number of times, and that basically means that this is a problem on binomial distribution. So the question is saying that, so the problem is saying that the probability of getting odd number, okay, probability of getting odd number 7 times, okay, so probability of getting odd number 7 times is equal to the probability of getting an even number, okay, 7 times is equal to the probability of getting an odd number 9 times. Okay, the probability of getting an odd number 7 times is equal to the probability of getting an odd number, okay, odd number 9 times. Okay, so that is basically the plot of the question, and if you solve this, then you must have been getting the answer of the value of n. Okay, so from there let me understand. So if I evaluate this particular scenario, so you can understand this is a binomial distribution problem. So 7 times, that is basically out of n trial, 7 times if you have to roll, and the 1 by 2 is the probability of success, that is getting an odd number 7 times, and 1 by 2 is a failure, that means getting an even number, that is n minus 7, and is equal to nc9 1 by 2 ki power 9 into 1 by 2 ki power n minus 9. Alright, so from here, if you evaluate the scenario, so you will get from here that 1 by 2 ki power n is equal to 1 by 2 ki power n, and also this particular scenario also equal to 1 by 2 ki power n. So this particular product actually get cancelled out, and if you cancel out this product, you are left with the quantity that is nc7 is equal to nc9. Okay, now from here, if you look at this particular scenario, that is nc7 is equal to nc9, the only solution or only case when it is equal to true, that is basically we have a property that is ncr is equal to nc n minus r. So using this particular property, what I can evaluate for, so using that particular property I can evaluate for, okay, so using the property I can evaluate for n minus 7 is equal to 9. That means n is equal to 7 plus 9, and that evaluates to 16. So if you look at this value of n, the value of n is basically 16. That means that dice are rolled actually 16 number of times. So we have to find for the probability of getting an even number twice. So finally we have to look for the probability of getting an even number, that is 2 times. Okay, so we have to get an even number 2 times. So if you look at this particular probability, that result will be nc2 1 by 2 ki power 2 and 1 by 2 ki power n minus 2. So if you evaluate this, is basically 16c2 1 by 2 ki power, so 1 by 2 ki power 16. Okay, and from the solution it is mentioned in the problem that is equal to k divided by 2 ki power 15, and that is basically given in the problem as k to raised to the power k divided by 2 raised to the power 15. So if you evaluate this, okay, so if you evaluate this result will going to be equal to, that is 16c2, that is 16 into 15 divided by 2 into 1 by 2 ki power 15, and is equal to k by 2 ki power 15. So 2 ki power 15 get cancelled with this particular result, and we are left with the result as k is equal to, so this is will be again 4 times, so the value of k is equal to 60. So from here the value of k will be equal to 60, and with this we have the right answer to this particular problem, okay, is basically option number B. Quite a very simple problem, but again a problem which basically gets repeated many times in the JEE Mains examination. The only thing was in the problem was to basically identify what type of distribution the problem was talking of. So with this, let us move to the next problem. So the next problem is again a problem where we basically have to look for, it is saying that n denotes the sum of the number which is obtained when the two dices are rolled. Okay, so basically two dices are rolled, okay, two dices are rolled, and n denotes the sum of the number which is obtained on both the dices. So if I say that two dices are rolled simultaneously, the first dice has a number alpha and second dice has a number beta, then n will be basically equal to alpha plus beta. Okay, so it is saying that if the two dices are rolled and the n is the sum of the number obtained on the two dices, the probability that 2 to the power n, the probability that 2 to the power n is less than n factorial is equal to what? Okay, so we have to evaluate for this particular scenario. Okay, so we have to evaluate for this particular condition. Now let us understand what this particular problem is trying to say. Okay, so if n is the denote the number sum of the numbers obtained on the dices which are rolled, and we have to look for this particular condition. Now what I can do, so what will be the maximum and the minimum value of m? So you can say that the range for n is basically the maximum value can be 12. Okay, that is both of the dices has a number 6 and 6, so that will be 12, and the minimum case is when both of the dices show 1, that is the sum will be equal to 2. So that means I can say that the value of n will range from 2 to 12. Okay, so the value of n will range from, okay, so all right, so the value of the n will actually range from the number 2 to 12. Okay, so what I can do from here, that I have to look for the cases when 2 to the power n is less than n factorial. Now I will go on putting the values of n as 2, 3 and simultaneously. So if I look at the case scenario, so if I look at the scenario, that is I will take the value of n as 2. So 2 to the power 2 is less than 2 factorial. This is fairly wrong. Okay, and similarly if you look at 2 to the power 3 which is less than 3 factorial, this is again wrong. So that means n value is not equal to 2 or not equal to 3. So again, now from the previous after that, if you look at 2 to the power 4, it is less than 4 factorial. Yes, it is true. Okay, because okay, if you it is basically less than or equal to, you can definitely consider for less than or equal to. Okay, okay, leave it, not for the less than equal to. Okay, sorry. So yeah, and that will be basically evaluating the result. That is true. That means the value of n actually ranges in the set 4, 5, 6 and up to 12. Okay, so these are the following possible values of n is equal to following. Okay, now I have to look for the probability that of this particular condition. So let me represent the condition that is by the say event e, and that is 2 to the power n is less than n factorial. So for this particular condition we have to look for, and this particular condition evaluates the case when n values ranges from 4 to 12. That means I have to look for the probability of e, and that probability of e will be equal to 1 minus probability of when n is equal to 2 minus probability when n is equal to 3, because these are the two conditions which are not included in this particular event e. So I hope from here if you calculate, the recurrent probability will be equal to 1 minus the value when is equal to 2, and that is basically the condition. Okay, so if you look at the dice, okay, so if I say the dice has a and b, and a has alpha and b as beta, okay, the summation of the number on the dice is equal to the case corresponding to the condition, that is 1 comma 1, and similarly alpha comma beta is equal to 3. This corresponds to the case 2 comma 1 and 1 comma 2. So there are basically 3 cases. Okay, so this particular has a probability 1 by 36, and this particular case has a probability 2 by 36. Okay, so if you look at this, they will have the probability, that is a recurrent probability is equal to 1 minus 1 by 36 minus 2 by 36. So if you evaluate this result is going to be 1 minus 3 by 36, and that is basically equal to 11 by 12. So if you evaluate this, the result is going to be coming out as 11 by 12, and it is mentioned in the problem that 11 by 12 is equal to m by n, and that is basically the where m and n are co-prime numbers. So from here I get the value of m as n 12, sorry, as 11 and n as equal to 12. So in the problem it is again asking for the expression 4m minus 3n. So 4m is equal to 44 minus 3n is basically 36. So if you evaluate this, the result is going to be coming out as, so this is the result is going to be 8. Okay, so from here the right answer to this particular problem is going to be option number C. I hope this particular problem is fairly simple. Okay, only this particular problem is the only condition that you need to understand. Rest the problem is fairly simple. Okay, I hope you have understood this particular problem. Quite an important problem. With this, let us move to the next problem. So the next problem is again a problem which basically talks about discrete probability distribution. Okay, again a question on discrete probability distribution. Okay, so we got a question on discrete probability distribution. Okay, it is saying that the x denotes the random variable. Okay, x denotes the random variable. Okay, x denotes the random variable, and the probability of the random variable is equal to small x is equal to k into k into x plus 1 whole into 3 raised to the power minus x, and where x values ranges from 0, 1, 2 and up to okay, all the integral values, where k is a constant number. So I have to look for, firstly, in this particular probability PMF function. So I have the PMF function. Now you must have know the definition of PMF. Whenever we have defined the probability distribution or PMF function, you must have studied this particular thing, that is the summation of all the values of x for x belonging to the sample space. Okay, x belonging to the sample space for all the random variable, the summation of the PMF function is equal to 1. So for all the values of the present in the sample space, if I sum up for all the probability, the result is going to be equal to 1. So from this particular condition, I will use this particular condition to evaluate the value for the constant, that is k. So if I look at this particular, and then I will get the summation as summation of k into x plus 1 into 3 raised to the power minus x. Okay, and if you evaluate this sum is going to be equal to 1 for x is equal to 0, 1, 2 and all the integral numbers. So I can write this as x belonging to all the positive integer. Okay, positive, or definitely write it as not positive integer, then better to write it as whole numbers. Okay, so x belong to the whole number. Okay, so whole number. So for this particular you have to evaluate. Now how can you solve for this? We have to basically use the infinite GP. Okay, so k is a constant, and if you look for the summation, that is x is equal to 0, so that will result in the case that is 1 into 3 to the power 0, that is 1, and 1 plus, and this is going to be 2 into 3 to the power minus 1 plus 3 into 3 to the power minus 2 and so on up to infinity, and that result is equal to 1. Now this is an interesting case over here. So this problem is basically a problem on probability, but this summation corresponds to a problem of a sequence series. So if you have studied the chapter, and I have already covered sequence series in my this short videos. Okay, so you must have understood as how to solve this particular problem. So the summation is basically 1 plus 2 by 3 plus 3 by 2 to the power 3 to the power 2. Okay, 3 to the power 2 and up to infinity. So how to solve this particular problem? So if you look at this particular problem, if you see that 1 by 3 is basically a problem of AGP. Okay, that is basically there is a AP in the numerator and GP as well as in the GP inverse. So it is a problem of AGP. Now to solve problems of AGP, we need to multiply the summation with the common ratio of the GP. So if you look at the common ratio of the GP, that is 1 by 3. So if you multiply the summation with 1 by 3, the result is going to be coming out as 1 by 3 plus, and if I shift the terms 1 over here, because infinity is something, a number which is uncountable or too large. Okay, so with this particular respect, I'm shifting the one term to the right side, and if I write it right side of mine. Okay, and if I write from here, so I am shifting this, and this is equal to 2 divided by 3 square and so on up to infinity. Now if you subtract the terms, the terms will be basically equal to 2s by 3. So if you subtract the terms is equal to, on the left hand side is 2s by 3 and is equal to 1 plus, this result is going to be 1 by 3 plus, this is again going to be 1 by 3 square and so on up to infinity, and this particular corresponding result correspond to an infinite GP. Okay, infinite GP with a ratio which is less than or equal to 1. Okay, with a modulus of the ratio that is less than 1. Okay, so from here if you evaluate this, the value of the summation, that is 2s by 3 is coming out to be, and we have already studied the sum of the infinite GP is going to be a by 1 minus r. Okay, so a is basically the first term. So if you look at the first term is 1, and the common ratio is going to be 1 by 3, so 1 minus 1 by 3, and if you evaluate this, okay, this result is going to be 3 by 2. So 2s by 3 is going to be 3 by 2. So from here the value of s is going to be equal to 9 by 4. So from here the value of s is going to be equal to 9 by 4. So we have the value of s as 9 by 4. Now so from there if I have to evaluate for the probability condition, then that is k into s is equal to 1. So I have the value of s is equal to 4 by 9. So I have the value of k as equal to 4 by 9. So the value of k is basically the constant value is equal to 4 by 9. So I have the value of the constant, that is 4 by 9. Now I have to look for the probability. Of x greater than or equal to 2. Now to evaluate this particular condition up to infinity, it is better to write this as 1 minus, where x is basically equal to 0, minus the condition when the random variable takes the value as 1. So if I evaluate this, now you can definitely evaluate because you have the PMF function. So that is basically 1 minus 4 by 9 into, and 1, okay, minus 4 by 9 into 2 into 3 ki power minus 2, that is 3 ki power 1. Okay, and if you evaluate this is going to be 1 minus 4 by 9 minus, and this particular result is going to be coming out as 8 by 27. 8 by 27. So if you can definitely evaluate this, and the result is going to be coming out as, so you can definitely do it. So you can take 27 as common, and 27 minus, so just need to multiply with 3, so 27 minus 12 minus 8, and if you solve this, this is going to be coming out as 7 by 27. So this is going to be coming out as 7 by 27. So with this, you have the right answer to this particular problem, which is equal to option number C. I hope this particular solution was clear. Alright, so fairly simple problem, but again an important problem, which basically involves the question of the basic of the probability, as well as the question on sequence and series. So I hope you will remember this type of problem. These type of problems are most prone to coming in an examination. Alright, so with this, let us move to the next problem, and the next problem is again a very important problem on Bayes theorem. Okay, so if you have studied, the Bayes theorem is very important. Okay, it is a question on Bayes theorem. So Bayes theorem is very important, okay, for exam purpose. Okay, if you look at the previous year question of probability of JEE advanced and JEE mains, you can find definitely like more than 50% of questions are basically framed from Bayes theorem only. So I would definitely recommend you to study Bayes theorem in like good details. Okay, so with this, let us study and what the question has to say. So in a bolt factory, so bolt is basically a nut bolt factory, and that basically has 3 machines. So machines are labeled as A, B and C, and it is said that the machine A produces 20% of the bolts, machine B produces 30% of the bolt, and machine C produces 50% of the bolt. Now it is said that out of their outputs, 3, 4 and 2% of them are respective bolts. So if the bolt is producing if the bolt is produced in machine A, the getting a defective bolt is basically 3%. So if I write the event as E of getting a defective bolt, okay, so E is the event of getting a defective bolt. Okay, so E is the event of getting a defective bolt. That means probability of getting a defective bolt, given that the bolt is produced by the machine A, is basically 3%, and similarly the probability of getting a defective bolt, given that it is produced by machine B, is basically 4%, and similarly the probability of getting a defective bolt, given that it is produced by machine C, is equal to 2%. Now if I have this particular condition, now I have to look for a bolt is drawn random from the product, and the bolt is found to be defective. So what I have condition, that it is already a defective, okay, a defective bolt is found. Okay, a defective bolt is already found. Now if a defective bolt is found, what is the probability that it is manufactured by machine C? So it is asking me for the probability of C, given that the bolt is defective. So this is basically a question on inverse probability, so it is, which is a problem of Bayes theorem. So if I have this particular condition, what I can do this for evaluating the Bayes theorem, you must have studied the Bayes theorem. This is probability of getting the, so if you look at this Bayes, if you do not remember the formula Bayes theorem, you can definitely use this as, so probability of produced by machine C, given that the bolt is defective, is simply a conditional probability, and this particular conditional probability actually evaluates as C intersecting E divided by the condition of E. And now probability of getting a defective bolt is basically given by the total probability theorem. So it is basically given by total probability theorem. So total probability theorem. Okay, now from here, if you have to evaluate this particular result, so this is basically again, now P probability of C intersecting E can also be written as the probability of C into by using the problems. With this, you will get this as probability of, and this can be evaluated probability of E, that is given that C has already occurred, divided by total probability theorem, that is probability of A into E given that A, plus probability of B into probability of E, given that B, given it is produced by B, so E produced by B plus probability of C into probability of getting a defective bolt, given that it is produced by C. And if you evaluate these particular results, so with this you can definitely evaluate. So the probability of producing by C is basically 50%. Okay, so that is 5 by 10. So I can write this as 5 by 10 into, and getting a defective bolt is basically 2%. Okay, and getting is basically 2%. So I can write this as 2 by 100 divided by, and if you evaluate this, these results are going to be 3 by 10 into 3 by 100 plus, okay, 3 by 100 plus, so from there, okay, so 20 by, sorry, so this will be going to be 2, because it is 20%. Okay, so this is going to be 2 plus 3 by 10 into 4 by 100 plus 5 by 10 into 2 by 100. So that is what is basically I'm using the conditions. I'm using just the result data from here and I'm calculating. So if you can definitely calculate it and you find the result as 10 by 28, and that basically evaluates out as 5 by 14. Okay, so that result basically evaluates out as 5 by 14, and that is basically the required answer for this particular problem, which is basically option number C. So if you have solved this particular problem, you must have got the answer as option number C. Fairly simple problem, but again problem of which is very important for Bayes theorem. Okay, so I took a problem on Bayes theorem. With this, let us move to the next problem. So the next problem is again a fairly simple problem of a dice. Okay, so it is said that 3 dice are actually rolled. Okay, so 3 dice are rolled, and if the probability of getting a different number on the 3 dice is basically p by q, where p and q are co-prime number, then I have to look for q minus p. So the total outcomes for 3 dice are rolled. So whenever the 3 dice are rolled, the total outcomes basically, so for first dice there are 6 outcomes into 6 into 6, and that basically evaluates us as 216 outcomes are possible for the 3 dice are rolled. And out of these 3 dice, the probability of getting a different numbers on all of these 3 dice are basically the number of. So fairly simple problem, which basically includes the concept of permutation and combination. Outcomes of getting different numbers on the 3 dices. Okay, getting a different numbers on 3 dices are basically given by so you have to basically have 3 dices. Okay, so you can assume the dices A, B and C, and getting a different numbers on the 3 dices out of the 6 numbers is basically the permutation of this 6 number in these 3 places, that is 6p3. So if you just have to permute for the 6 numbers in these 3 places, and that's basically the result for getting the 3 different numbers on these 3 dices. So that basically evaluates as a 6 factorial divided by 3 factorial, and that is basically equal to, so if you evaluate this, it will be coming out as 120. Now the required probability will basically evaluate out as, this is the favorable case and the total case is 216. So favorable by total cases, that is 120 by 216, and that basically if you simplify this is going to be 5 by 9. Okay, so if you can evaluate this is basically coming out as 5 by 9, and where 5 and 9 are basically co-prime numbers. So that means basically p is equal to 5 and q is equal to 9. So q minus p is basically going to be coming out as 4, and that's the required answer to this particular problem. And with this, the right answer to this particular problem is going to be option number B. Alright, so fairly simple problem, again an important problem which involves the concepts of permutation. So I took this particular problem. Alright, so that's how we basically come to the end of this particular video sessions. Okay, where I have covered the top 10 important questions on the probability. Okay, so you must have understood these concepts of probability. Okay, so these are very important problems, not very difficult, but they basically involves quite a bit of logical thinking. So if you are good with logical thinking and have studied the chapter of permutation and combination, then you are good to go with the chapter of probability. So the next video is going to be on the topic of statistics, and these 3 parts, that is permutation, combination, probability and statistics, is going to be of good weightage in your JEE Mains examination. Alright, so with this I come to the end, and thank you.